Welcome to this episode of Let's Be Civil. My first guest on Let's Be Civil is Marcus Quigley. Marcus is an entrepreneur whose expertise is solving complex civil and environmental problems. In 2019, he founded the Boston-based company Ecolucid. He's the technology practice lead for the Environmental Finance and Consulting Group, where he was CEO and member of the board from 2014 to 2019. Previously, Marcus was a water resource consulting engineer. I want to welcome everybody to Let's Be Civil, the podcast for civil engineers. And today I've got a friend of mine, Marcus, who's out in Boston today. As you guys all know, nobody's near anybody. So things are working out for a podcast. But we're going to talk a little bit today about innovation, about imagination, about entrepreneurship. Which is something I think near and dear to both of our hearts. Would you agree?
Oh yeah,
with
absolutely.
That? Yeah. So why don't you give us a little, the 30 seconds background on yourself?
Yeah, great. Yeah, thanks, John, for having me too. And I think this is pretty exciting to be able to kind of share these conversations, particularly with undergraduates and people that are thinking about civil engineering as a career or already in it, or early career professionals in particular.
Sure.
But just a little bit of background on me. I'm a water resources engineer. I've done a lot of things, but when people ask me, I lead with that. I'm a professional engineer as well, and I've been working in this direction in a concerted way, even when I was fairly young, focused on being very interested in the environment. And when I got into undergrad, I was deciding between information technology and civil engineering. And I liked really physical, interesting things and water in particular. And so I went a route undergraduate at Notre Dame. And I went a route that was a combination of environmental science and engineering in undergrad. And went into graduate school at Oregon State. And focused on water resources engineering, which is where my career has been as well.
So if you look in the back, you can see where I'm from.
I'll have to
I don't know if you can take a peek on the shelf behind me.
Oh, I can see some helmets.
Yeah.
So you'll have to.
Oh, yeah. So Packers, Badgers, and Brewers.
Oh, excellent. Yeah, that's good. It's good. Good Midwest roots, right?
Yeah. That's not where I'm sitting, by the way, but that's just background. Yeah.
That's great. So, in graduate school, I at first thought groundwater looked really particularly interesting, but I got an opportunity to work on surface water in a research assistantship at Oregon State, and really I've been focused primarily on surface water, but have branched out, as you'll hear, into a whole bunch of other things over the years, which has made it a really exciting career. I think particularly one of the things that I've enjoyed is that there's so many interesting problems out in the world, and I find the interesting ones and tend to pursue them. So graduate school, I actually got a really nice opportunity in graduate school to work on a project for the National Cooperative Highway Research Program.
Right.
That was very consulting-like. So it was funded with FHWA and DOT money, but the environment I was in was a really nice place to be, where I was working on research, but also had this consulting activity going on where I had to present to the oversight board and the advisory board and put formal reports together. In a real cadence and kind of driven as a project schedule, which was a nice entree into where I started at a company called Woodward Clyde, which is a consulting engineering firm that actually got bought shortly after I joined by URS, which is now part of AECOM. And I spent a few years there, and then had the opportunity to join what at the time was a 300-person or so firm that had just started a water resources practice. So I was kind of mid-20s, had done some really interesting work at a national scale in consulting at Woodward Clyde and URS, and then joined a firm that was really starting a water resources practice. So I was the third employee in water resources at that company. And then over the next 15 years, we grew that group to close to 150 people. The firm grew from 300 to 1,200. And I opened up an office of the firm, had the opportunity to be on the board of directors, became a senior principal. So out of 1,200, there are about 60 of us that are at the principal level, and worked at every state in the country. Really went after things that I was very passionate about. I mean, I kind of loved this stuff my whole career, but intentionally sought out things that were very challenging and helped people do things that were really interesting, and that worked quite well. And so I had this career in consulting for close to 20 years. Along the way, I built what became a separate company as what you call a classic entrepreneurship opportunity, right, or approach, where essentially you're building a new company, but inside of a company. I didn't know it at the time, of course, but we eventually created, that became its own P&L, and we spun out a company that then I became the CEO of and ran for 4 years. And I stepped back from that in 2019. And then I started a new company now that I'm running that's in consulting as well. So one thing I will say that's a hallmark across all of this is really being open to change and pursuing interesting things, finding great people to work with. But that's a kind of an overview of my career. So
sure. So I've got a comment for you, and I think I've mentioned this to you before, but in full disclosure, I was a stalker of you professionally, which I think you know.
In a good way, right, John?
Yeah. Right. Yes, in a good way. But I came across you around the time I think that the company spun off the company or early on in that process, and it just been keeping my eye on the stuff that you've been doing, and then when we had the opportunity to have you come to Texas, it was like, here's the shot.
Well, it's a unique story too. There's not that many examples of technology companies. This is a SaaS, Internet of Things company that came out of a consulting firm, was well capitalized, created as an independent company, and then it's still doing well. So it doesn't happen that often. There's lots of entrepreneurship happening at large companies. And I think it's actually a very exciting place to be. It doesn't get talked about as much, but the vast majority of all innovation is happening inside of larger companies in the country, around the world.
So the other thing that kind of plays into this, because I think it did for me in terms of things I chose to do, was not just changing who I worked for or with, but where.
Yes.
So as you traversed your career to today, how many places have you lived? How often have you moved?
So I was actually part of a military family growing up. So it may just have been kind of in my upbringing too. Sure. But so I went to undergrad at Notre Dame. I went out to Oregon State, which is actually, for a lot of people, that's a pretty big change of venue. It didn't feel particularly daunting or different to me. And then I started my career in Portland, Oregon, right out of graduate school. So I, from Corvallis, I just went a little bit north. And then I moved out to Boston. Yeah, and it was a change. And then I moved out to Boston. I transferred with Woodward Clyde at the time, and I've been here since. Right. But one of the interesting things, even when I think about the project work, I mentioned that I'd worked all over the country. is that the vast majority of my work hasn't been in Boston or even regionally here. A lot of water resources work around the country. There's interesting things going on all over the place. I got my PE first in California, for example.
Sure.
Yeah, it's been really important to have that broad geographic perspective, and it really means that I've learned about what's going on all over,
Right.
and that's been a great benefit too.
Well, and that's why I bring it up, because I think it's important for young professionals to understand that there's value, there's benefits to being in different places. Exposure to different parts of the country, to different perspectives on the same problem. I just personally think if you don't see those things, then your imagination, your innovation kind of becomes constrained, because you're not having things fed into you by other people.
Yeah, and I think in general, creativity and imagination and entrepreneurship, which stems from that, it's about synthesizing ideas and exposing yourself to enough interesting things. And that's at least where my inspiration always comes from, is interacting with really interesting people, challenging myself to learn about things I don't know about, going into geographic locations and having personal interactions that are like uncomfortable at times or different, or but it's that exposure. And I think that, we have this myth of genius in our society around even the stories of tech titans, entrepreneurship. How do these things get created? And it's like somebody sitting in a room somewhere had an idea, and they made it happen. And I think it's not like that at all. When it really comes down to it, it's about all these little tiny decisions that you make, getting yourself from a statistical perspective in enough places to be in the right place at the right time, and to put the pieces together. That's a lot of hard work. It's always kind of being optimistic about where things are headed, and just being open to putting new things together in new ways. I think anybody can do that. It's more of a mindset than it is. Certainly, it's not some innate capability. It's something that everybody has inside of them. And I think the hard part is just the hard work. A lot of entrepreneurial stories also don't sound like a lot of hard work, and anything couldn't be farther from the truth. And the fact that it's just like, you got to show up, you got to work long hours, you've got to love what you're doing, and if you put all those pieces together, like it will head in the right direction.
And you've got to solve all the problems.
Yeah, that's right.
I mean, it's on you.
Yep. Well, I'd add that on. I think that's right, John, is taking on responsibility. If there's something that I would say is like makes you learn more quickly than anything else, is taking true responsibility for things. And I think it's not a model that we see a lot of our leaders, particularly in recent times, exude, which is if you're saying, I'm going to be the CEO, or I'm going to lead a committee, that you're responsible for everything everybody does, whether or not you made the decision, you're responsible. And taking that on in a very serious way holds yourself to a very high standard. And that's a good, put yourself in that position, back yourself into a corner to take on that responsibility, and then you have no choice, but to really do I think great things.
Well, when you talk about it, it doesn't take genius to do these things. So I went to North Carolina State for my PhD.
Yeah, great school.
And I worked for Dr. Paul Zia. He was my advisor. He became president of the American Concrete Institute. He had a very storied career. Um, and I remember one day being in the hallway, and he looked at me and he goes, someday you're going to end up writing a book. And I said, no. I said, I appreciate, the thought, but I don't see that in me. Yeah, this is early, time in my 20s.
Yeah, yeah.
And he said, no, I can see that you're going to do something like that. And I just said, I just don't feel like I have the imagination. I don't feel like I think of things. I'm spending my day doing, because you want a dissertation from me, and so I have to do. But later on, and it is like what you were saying. It's kind of a series of steps. I found myself in a situation where I had worked on an idea, was kind of building on that idea, and decided to make the switch from what I was doing and commit to that idea.
Excellent.
And and then that like, that's why I say the problem solving is you, because I tell people this every once in a while, but I actually was streaming content from my company to my cell phone before the general public knew what streaming was.
Yeah.
Sprint sent me a nice bill for doing something I was not supposed to be doing, but it was, I could see where what we were doing was going to lead to online delivery of content, and ultimately to a phone. And stuff just started popping into my head. And I started to figure out, well, if this idea is there, how would you make this work?
Yeah,
so I remember sitting in my office and looking at my phone and going, holy, this works.
And that's I had the same exact experience, which is like the things that have been most interesting, particularly from a technology perspective, that I dove into that turned into something. I didn't have any idea in the beginning that that's where I was headed. But once you engage, once you start thinking about those things, new things show up and new connections get made. I mean, it's just pretty incredible, actually. You talk to people and you find little pieces that you didn't think about, and you add them on to what you've been doing for 5 or 6 years in the back of your head. You're thinking about them all the time. And every once in a while you see a path that is like a really interesting path. And hopefully nobody's been on it, and especially integration of kind of ideas looks like that.
Tell me how often people commented to you that, this probably won't work, or or nobody's really there's not a market for this. I got a lot of that, so I'm wondering from you, did you?
Yeah, no, I think quite often. I think particularly around business models and the technology as well. If you're kind of out at the edge doing interesting things, there's a reason other people haven't done them, and there's a lot of risk. These types of things, your personal risk, technical risk, you're going to get things wrong along the way. Things aren't going to go exactly as you might expect, particularly when you're a very optimistic person and you take risk on often. It's like surprising sometimes when it doesn't work out. But very often, I think, I will say I've had, as you did too, some really great mentors that have just been deeply supportive, not of like ideas, but me as a person. And that's been, that'll carry you through. Find those people. I think the best way to do that is find people that are doing really interesting things and just help them do them. And you'll learn and expose yourself to all incredible things. It sounds like you're a professor. I had same experience in graduate school. Wayne Huber, a giant in surface water modeling, one of the original authors of the swim model, was my major professor at Oregon State. And, he did that. He said, you want to come work for me? And it's like, yeah, fantastic. You know,
Right.
I was
Right.
like 22 at the time or something. And I just sunk everything into helping him be successful at the things he was doing. And I did the same in consulting everywhere along the way. I still do it with my clients. It's like, find really interesting clients that are doing have big problems and help them solve them, and you're going to be, you know, in an interesting place. But yeah, I think there's a lot of folks that, particularly around entrepreneurship and kind of creative ideas that you know, at times feel that's like threatening, or it's challenging, or it's a waste of time. And sometimes it is. I mean, they're right at times.
Right. Right.
But I think that deep optimism is really important.
Is there s-
Yeah.
is there something that you're doing now that you can talk about that might be somewhat out on the edge? You know,
Yeah.
maybe not
I didn't talk.
mainstream, but
I didn't talk explicitly about what I'm doing now, and it's actually so I stepped back from running a technology company, a software as a service, direct control of civil engineering infrastructure company, and I'm doing consulting for actual projects. There's some really interesting work there. It's still at the intersection of information technology and civil engineering
mhm,
in most cases, but also solving, you know, concrete problems in creative ways. A lot of stormwater work, because that's one of the things I focused on. But I also wear another hat. I'm the and this is probably maybe the more interesting. And they're both interesting, but from relative to your question, um, I am the technology practice lead at a group called the Environmental Finance and Consulting Group. And this sounds funny, but we're consultants to consultants. So I have the opportunity to advise senior executives at civil engineering firms around technology strategy. And this is an interesting place to be, because it allows the opportunity to think very broadly about where this entire industry is headed, and to, you know, help with that, you know, forward-looking strategy for these businesses. You know, it's technology, but it's also a lot about how do you actually get it done in very kind of conservative, slow-moving, you know, settings, which civil engineering in some ways is. I mean, for good reason.
right.
Too, we've got important things to do, and we better do them right. But yeah, I think that's some of the most interesting work, because we get to look out 10, 20 years around how do you take a, you know, billion-dollar company and position it so that it's ready for where we'll be in 20 years. And there's just dramatic change. I mean, there is across society around technology, but civil engineering is particularly exciting, somewhat because we've lagged. You know, consumer technology, as we, you know, here we
Right.
are on
Right.
Zoom,
Yeah.
has progressed incredibly fast.
Right.
And you know, civil engineering is just catching up to it. What does all this mean? You know, one area that jumps out at me is low Earth orbit satellite imagery, so, and remote sensing. And we've used remote sensing very effectively for a long time now. GIS really came out in the early 80s. It's about the same time AutoCAD came out, and you know, we had Landsat and kind of early sources. But over my career, we've gone from film cameras to the low Earth orbit satellites. Now we can get a picture um, every day of every point on Earth at around, you know, 1 sub-meter resolution. And we have about 2,000 satellites in orbit right now. You know, a few hundred of those are focused on Earth observation. In the next few years, we'll be launching as many satellites as we have in totality each year. And it's just a whole different thing. And in 10 years, we'll be at a place where many times per hour, we'll get sub 25 centimeter resolution imagery of every point on the globe.
Yeah.
And I think it's really hard to even understand like what that kind of detailed level of always on observation, particularly for civil engineering, means for the practice. And we talked a lot about drones or aerial imagery, and it's like we can get that all the time, always on. You know, watch trucks move around a construction site during the day. from satellite, which is a whole different place to be.
So you know you're coming to Texas and to Texas State had a lot to do with the fact that we have a new civil engineering program at Texas State that is as much focused on technology as it is on classic civil engineering. And so we have, you know, we're actually trademarking the term technology enhanced infrastructure because of the, you know, the focus on this with this, you know, mindset that in 4 years, these first students in the program are going to be stepping into career paths that technology is going to matter. One of the things that I see, and I'd be curious to your concept, your thoughts on this, is there are things that we have done for a long time that now we're looking at in a different way. So I'm going to use the strain gauge. The strain gauge is a very simple device. It's been around for a long, long time. But where did we use strain gauges? In research in a lab.
Yeah, that's right.
You know, no one ever said, let's put a strain gauge out in the field and actually leave it there for the duration of the life of this structure.
Right.
Let's watch a particular part of the structure and actually understand what is truly happening. You know, and so I think a lot of stuff from the civil engineering perspective that's going to change, that will be simple to change, is just our view of things we're already doing, but do them in a different way or use the technology in a way we just didn't really ever contemplate before.
Yeah, that's right.
Then there's going to be the new things. You know? So real quick, before you jump in, we are looking at things that you are going to validate existing technologies. You know, we ought to be able to validate existing technologies, evaluate emerging technologies, and you ought to be in some way able to create new technologies. So those are kind of three things we think are going to be important for civil engineers to adapt into civil engineering infrastructure analysis and design. So
yeah, it's just the strain gauge is a good example too. You know, there are all these secondary effects by putting sensors out into these environments that aren't at first obvious. So like, let's say you put a strain gauge on a truss on a roof on a warehouse, and you could monitor that for kind of conventional reasons. You know, looking at making sure that the snow loads aren't too large. And maybe you could decide when you actually need to shovel the roof. Like very kind of simple things. Maybe the obvious civil engineering thing is just look for fatigue and, you know, potential failure. Sure. If we can get them cheap enough and put them everywhere, we can prevent, you know, collapses and these types of things, or structural failures. But you get these, you know, secondary effects which are fairly obvious, like, oh, we can monitor snow loads. But then you think, wow, we just created, let's say you've got 100,000 warehouses with millions of strain gauges. You all of a sudden have a monitoring network of actual snow loads for all buildings across large geographic areas. And instead of having, you know, these weather gauges that are specifically out there monitoring what's happening with snow, you now have millions of observations about what's happening with weather and snow loads and melting and ice.
And it's automated.
And you never set out to do that. Right. So you created an entire monitoring network. There was one, we saw glimmers of this, and I don't think we're there yet with large kind of semantically consistent monitoring networks across wide geographic areas. But at the company I ran, we had large numbers of sensors spread out, and a couple of things happened that were global. One was a solar storm that happened one time. And then the other was the eclipse, which was really interesting. We had this major eclipse and was a big deal. I think this was like 2 years ago. Right. And our systems were not set up to monitor either of these things in any kind of effective way. And yet you could look across the entire network and observe both things very well. We could literally watch the solar eclipse move across all of the solar panels just from the power systems, not because they weren't monitoring solar energy, but they are.
Right.
So those aren't like particularly commercially interesting, but you start to see the same idea, like what does it mean to have millions or tens of millions or billions of strain gauges all around the world? You're going to monitor things you never really understood. Even wind gusts you could see on strain gauges, right? What are hyperlocal, extremely transient wind gust forces on buildings? I don't know. We haven't studied that.
Right.
So
Right.
really interesting stuff.
Yep. Well, now sort of another perspective we have is the built environment is a living laboratory.
That's right.
If we go and we install devices in structures, then just what you're saying, if I have several structures in a city with the what we say event detection devices, that if there's a windstorm that comes through, we'll be able to pick that up in terms of how is the wind actually moving through and around all of the buildings. And so model nothing. I'm actually collecting real data, you know?
That's right. It's interesting too. You know, I spent my graduate work on theoretical models, using lab data to calibrate them, of course. But this shift to, and I think your program does this quite well, but the realization that we're shifting into this empirical environment, much more so over theoretical. You know, if you've got all those buildings instrumented, it's one thing to do a CFD model of wind propagating through like an urban core or something, and looking at all the forces on the buildings. But if you can observe that empirically, I think we're learning new things that the theoretical models, you know, don't entirely address.
Right.
So particularly very kind of short time scale, transient behaviors, and kind of you know, systems level complexity that is kind of beyond the theoretical side. Even like CFD, you've got to, you know, you do all of this averaging of behaviors, and the true transients are not really modeled in CFD. So
well, you know, and part of all this too is that we now have the ability to store the information. We have the ability to analyze it.
That's right.
You know, years ago we didn't have the ability to do those things, which
that's right.
And it's like anything else, you need certain things to happen for you to take that next step. And now we're at a point where we can do things for the civil engineering profession for the betterment of the common good. That we couldn't do before. And so the students that are coming, you know, into civil engineering programs today and in the future have to be able to understand these things, because it's actually going to become part of their profession.
The other thing, just because I know we're getting toward the end here, that I think is really important, particularly in a world that's changing so quickly on the technology side, is for civil engineers and just people in general to pick problems that they really want to solve. So there's this tendency, even you and I are doing it, right? Like we're really interested in strain gauges. We want to talk about satellites. We want to talk, you know, I mean, like we're engineers, we are interested in the technology. But in the end, if you try to find problems, you know, underlying problems that you're really interested in solving, and focus on those, and then back into and look for technologies that can help you get there. And there's an interplay. I mean, you can all do that in isolation. You say like, boy, remote sensing looks really interesting. Like, what's all the kinds of things I like that technology, but like, what kind of problems do I want to solve? You'll end up in a place that's very fulfilling, I think. And you'll be passionate about it, and you'll put the time in, you'll do the hard work, because and you'll be able more when you've had a longer term career, you realize like you got to move with the technology and stay. Things aren't going to be the same.
Right.
You can easily like specialize in some technology, and the world moves around you. But if you're focused on the problems, you're always at the forefront.
Yeah. Well, I think what you're doing today in your career is interesting because you're doing something, a part of what you're doing is civil engineering work, and a part of what you're doing is really not civil engineering work.
Yeah, that's right.
I mean,
it's more about human systems when it really comes down to it, figuring out how you build companies that are effective, how do you interact with cities. It's particularly when I was starting out in Internet of Things, I was so enamored by the technology. And the work at that time was incredibly difficult because a lot of the systems didn't exist. That's changed in a significant way, even in the last year and a half. That these systems have really matured. And some of the things you could have gotten a PhD in 3 or 4 years ago on the technology side, right now your committee probably would say that's like too much of a technology approach, and frankly, it's already been solved.
Right.
But back then, you could have done it. It's not that long ago, but it's true. But we're now in this place, particularly around things like smart cities, Internet of Things, where the biggest challenges are how do we build things really well that fit into human systems and how we actually function. I mean, this crisis we're in right now around the pandemic is almost entirely about human systems, and how do they, when you disturb them, how resilient are they? And we're finding out not that resilient. I mean, particularly our economy is not that resilient to perturbation. So yeah.
Well, I think from our conversation, tell me if I think you'll agree that to be innovative, to be an entrepreneur, you don't have to be a genius. You don't have to have earth-shattering ideas. I think what you were saying before about, work with interesting people and work on problems that are interesting to you, that's going to lead to that imagination coming out. And
that's right.
I mean, and some of it is, there are going to be people that are interested in being an entrepreneur, and there are going to be people that are not. And so I think in addition, you don't have to feel like this is something that is expected of you in your career, that somehow you
absolutely.
Just like anything else, it's not for everybody.
And I said it at the outset. I mean, some of the most interesting work is getting done in places that don't make the front pages and are not the kind of the myths that we kind of float around. Entrepreneurship has all this gloss on it. But the work being done inside large companies, the work being done in government right now, particularly at the city level, there are just some incredibly interesting and exciting things. I mean, I've had a number of people tell me this, like, you want like great budgets, big problems, the freedom to do things. A lot of utilities are the place to be right now. Not all of them. I mean, there are different types of environments and utilities, but there are some incredibly interesting places to be where you find very, very fulfilling careers that have kind of all the characteristics we're talking about. But, like a mid-level researcher at a large utility is not the dreams of Silicon Valley or something. But I'll tell you, I think it's a very exciting place to be at a personal level.
Yeah. Well, I want to thank you for spending some time with me today. Great conversation. Enjoyed it tremendously. I hope to have you back to Texas sometime soon when we can move around a little bit. And we were hoping to have our second meeting in the fall. I'm not sure, that's going to happen this year. But I mean, that's okay. We'll who could have thought that something like this would be in our backyard.
Yeah, and I'm sure Texas State's is rising very well to the occasion, and
I think it's people getting after it. I mean, it's interesting. People are getting after it. So, so thank you for joining me on Let's Be Civil. Hope to have you back on sometime when you've got something that you want to share that is new, exciting, when you can start to tell us a little bit about the
that sounds good.
things you're actually doing.
Absolutely.
Have a little different conversation on what's actually happening with you in your career today and the work that you're doing today.
Yeah,
but-
that sounds
but-
great, Sean.
Yeah, but I appreciate it. So have
Keep-
a good day, sir.
Yeah, keep up the good work, and glad you're doing this whole series too, John.
Yep, appreciate
a
it.
lot.
Thanks.
Yeah, take care.
See you.